We have to rewrite every single high school textbook on the planet Earth. The universe is not mainly made.
Imagine staring into the night sky, a canvas of twinkling stars stretching into infinity, and realizing that everything you thought you knew about the universe, its past, its present, its future, might be wrong. The cosmos, that vast, mysterious expanse we've spent centuries trying to decipher, is whispering secrets that don't fit the story we've told ourselves. Renowned physicist Michio Kaku, a man who spent his life chasing the universe's deepest truths, has issued a warning that sends chills down the spine. Our understanding of the cosmos is unraveling. The James Webb Space Telescope, the Dark Energy Spectroscopic Instrument, and a perplexing puzzle called the Hubble tension have revealed cracks in the very foundation of cosmology. These discoveries aren't just tweaking the edges of our knowledge. They're threatening to rewrite the entire story of existence. High school textbooks, once thought to hold the final word on the universe's workings, are now obsolete. The universe isn't what we thought it was, and what lies ahead could be stranger, more awe-inspiring, and more uncertain than we ever imagined. The trouble began with a number, a deceptively simple measurement that's turned the world of cosmology upside down. Scientists have long relied on two trusted methods to measure how fast the universe is expanding, a value known as the Hubble constant. One method peers back to the universe's infancy, studying the faint glow of the cosmic microwave background, the echo of the Big Bang itself, captured by the Planck satellite. It tells us the universe is expanding at about 67 kilometers per second per megaparsec, a steady, predictable stretch of space. But when astronomers look closer to home, using pulsating stars called Cepheids and exploding supernovae to measure distances in our cosmic neighborhood, they get a different number: 73 to 74 kilometers per second per megaparsec. That gap, a mere 7 units, might seem trivial, but in the precise world of cosmology, it's a catastrophe. It's as if two master chefs using the same recipe baked cakes that came out tasting entirely different. For years, scientists clung to the hope that this discrepancy, dubbed the Hubble tension, was just a mistake, a glitch in our instruments, or a miscalculation that better tools would resolve. But in early 2024, the James Webb Space Telescope, with its razor-sharp infrared eyes, delivered a verdict that silenced those hopes. The telescope's measurements of Cepheid stars were impeccable, confirming the higher expansion rate with chilling certainty. The tension is real. It's not going away. Nobel laureate Adam Rees, who led one of these studies, put it bluntly: "We've negated measurement errors. What remains is the real and exciting possibility we have misunderstood the universe. The standard model of cosmology, the bedrock of everything we thought we knew, is crumbling. This crisis isn't just about numbers. It's about the story of the universe itself. For decades, we've pictured the cosmos as a grand, predictable machine, governed by a model called lambda CDM. It told us the universe is 5% ordinary matter, 25% dark matter, and 70% dark energy, a mysterious force pushing space apart. This model explained everything from the Big Bang's afterglow to the formation of galaxies, and it felt unshakable. But the Hubble tension is a crack in that foundation, a sign that something fundamental is missing. It's as if we've been reading a book about the universe, only to discover entire chapters were written in a language we can't understand. The James Webb Space Telescope's findings have deepened this mystery, revealing galaxies that shouldn't exist. When it turned its gaze to the farthest reaches of space, peering back to just 300 to 400 million years after the Big Bang, it found something impossible: massive, mature galaxies teeming with stars and heavy elements, structures far too advanced for their age. According to our models, the early universe should have been a sparse, chaotic place, filled with tiny, primitive star clusters slowly knitting themselves into galaxies. Yet there they were, these cosmic giants, glowing with the confidence of systems billions of years older. Astronomers were stunned. One NASA report called these galaxies an unexpected population that's electrified the community. Star formation, it seems, was happening at a ferocious pace when the universe was barely a toddler, challenging decades of established theory. If these galaxies are real, our entire cosmic timeline is wrong. The weight of these discoveries presses down like a storm cloud. Every new piece of data from the James Webb Space Telescope and other instruments seems to pull another thread from the fabric of our understanding. Scientists are calling this a full-blown crisis in cosmology, a moment where the rules we've trusted for decades are failing us. But amid the uncertainty, a bold idea has emerged, one that could tie these mysteries together. Researchers at MIT and the University of Texas have proposed a radical revision to the universe's earliest chapter, a fleeting burst of early dark energy, a force far more potent than the dark energy we know today, may have surged through the cosmos just 50,000 years after the Big Bang. This wasn't the steady, invisible push we associate with dark energy now, but a violent, short-lived explosion that reshaped the universe's infancy. Picture it, a newborn cosmos, still glowing with the heat of creation, suddenly stretched by this mysterious force, shrinking the sound horizon, the cosmic yardstick we use to measure distances in the early universe. This tweak could reconcile the conflicting Hubble constant measurements, making the numbers align at last. But it does more than that. This early burst would have made the universe slightly older and less dense sooner than we thought, creating the perfect conditions for those massive, impossible galaxies to form at breakneck speed. Simulations show that with this early dark energy, bright, star-packed galaxies could have emerged in the universe's first 500 million years, exactly as the James Webb Space Telescope observed. It's a solution so elegant it feels like a gift, a single idea that could solve two of cosmology's greatest puzzles. Yet the universe isn't done surprising us. In April 2024, the Dark Energy Spectroscopic Instrument, or DISI, unveiled a discovery that sent shockwaves through the scientific community. This instrument, mapping millions of galaxies across billions of years, found patterns that don't quite fit our assumptions. For decades, we've treated dark energy as a cosmological constant, an unchanging force driving the universe's accelerating expansion with relentless consistency. But DC's data suggests something wild. Dark energy might be weakening. The galaxy distributions it mapped are slightly off-kilter, hinting that this anti-gravity force, which makes up roughly 70% of the universe, may have lost strength over cosmic time. Adam Rice, who helped discover dark energy in 1998, called this the first real clue we've gotten about its nature in 25 years. If true, it means the universe's expansion isn't a fixed, runaway train, but a dynamic process, slowing down in ways we never anticipated. This isn't just a tweak to the math, it's a revolution in thought. A weakening dark energy could mean the universe's acceleration might eventually stall, or even reverse, over timescales so vast they dwarf human imagination. The cosmos, once thought to be racing toward a cold, eternal sprawl, might instead be preparing for a dramatic shift in direction. These revelations stir a mix of awe and unease. We stand on the edge of a cosmic precipice, staring into a future that's no longer certain. The universe is alive with secrets, and each new observation pulls us deeper into its mystery. Michio Kaku, with his lifelong passion for unraveling the cosmos, sees these discoveries as pieces of a grander puzzle, one that might lead us to a theory of everything, a framework where quantum mechanics, gravity, and these cosmic anomalies finally make sense. But for now, we're left with questions that burn brighter than the stars. If dark energy is fading, what does that mean for the universe's fate? Could the cosmos slow down, stop, or even collapse in a fiery reversal of the Big Bang? Or are we merely witnessing a fleeting moment in a cosmic dance that spans hundreds of billions of years? The universe is speaking, and we're only beginning to understand its language. The universe is a storyteller, and its narrative is growing stranger by the day. We stand at a crossroads where every new discovery feels like a page torn from a book we thought we understood. Michio Kaku's warning echoes in our minds. If we're wrong about dark energy, we're wrong about the future of everything. The James Webb Space Telescope and the Dark Energy Spectroscopic Instrument have already shaken our foundations, revealing galaxies too mature for their time and a dark energy that might be fading. But there's another layer to this cosmic mystery, One that makes the stars themselves seem like mere props in a grander drama. Time itself, the universe's silent metronome, is ticking in ways we never expected, and it's forcing us to rethink the very nature of existence. Picture the early universe, a billion years old, still a child in cosmic terms. Scientists have long known that time behaves strangely in an expanding cosmos, thanks to Einstein's genius. As space stretches, light from distant objects takes longer to reach us, making events far away appear to unfold in slow motion. This effect, called time dilation, is like the universe's own clock, ticking slower the farther you look. For years, though, spotting this slowdown was maddeningly elusive. Early studies of flickering quasars, those blazing hearts of ancient galaxies, showed no sign of the expected lag, leaving some to wonder if our models of expansion were flawed. But in 2023, a breakthrough changed everything. A team led by Geraint Lewis studied quasars from when the universe was just a billion years old and found time crawling at one-fifth the speed of today, exactly as Einstein predicted. Meanwhile, the Dark Energy Survey's observations of distant supernovae confirmed it further. Their light curves stretched precisely as expected. One scientist, barely containing their excitement, said, "It's blindingly obvious from the data. These cosmic clocks, ticking slower in the deep past, prove the universe's expansion is real. No simulation, no illusion. But they also give us a tool, a way to measure the cosmos with such precision that we can detect the faintest hiccups in its rhythm. This precision is why the James Webb Space Telescope's latest feat feels so monumental. It spotted a galaxy just 280 million years after the Big Bang, the earliest cosmic clock we've ever seen. Imagine that. A galaxy born when the universe was barely a spark, its light traveling for nearly 14 billion years to reach us. This discovery isn't just a record breaker. It's a window into a time when the cosmos was raw and chaotic, yet somehow birthing structures far more complex than we thought possible. These findings deepen the mystery of the early galaxies, those impossibly mature systems that defy our timelines. If time itself is stretching in ways we didn't predict, if the universe's clock is ticking to a beat we can't yet follow, what does that mean for its future? The Hubble tension, with its conflicting expansion rates, already suggests our measuring sticks are misaligned. Now, with time dilation confirming expansion, but hinting at subtle shifts, we're left wondering if the universe's pace has always been as steady as we assumed. Could it have sped up, slowed down, or wavered in ways we're only now glimpsing? This question leads us back to dark energy, the invisible force driving the universe's acceleration. The DESI team's findings, that dark energy might be weakening, aren't just a curiosity, they're a seismic shift. For decades, we thought dark energy was a constant, a relentless push sending galaxies racing apart forever. But if it's fading, the universe's future isn't the cold, empty sprawl we imagined. Instead, it might slow to a halt, galaxies drifting to a standstill over trillions of years. Or, in a twist that feels like science fiction, dark energy could weaken so much it flips, becoming an attractive force that pulls the cosmos back together. Imagine galaxies rushing toward each other, the night sky blazing brighter as stars and planets collide, culminating in a big crunch, a fiery collapse that might spark a new Big Bang. This isn't wild speculation. It's a possibility grounded in the data, a hint that the universe might not be a one-way street, but a cycle of creation and destruction, a cosmic heartbeat pulsing across eons. Michio Kaku sees this as more than a crisis, it's a doorway. His work on string theory and higher dimensions suggests these anomalies aren't accidents, but clues to a deeper truth. What if the Hubble tension isn't just a measurement glitch, but a whisper from extra dimensions, or even other universes brushing against our own? The early dark energy pulse proposed by MIT researchers could be a ripple from such unseen realms, a force that briefly reshaped our cosmos before vanishing. Kaku has long argued that our universe might be one of many in a vast multiverse, each with its own rules, its own physics. The conflicting expansion rates, the two early galaxies, the shifting dark energy, all could be signs that our universe is entangled with something bigger, something we can't yet see. It's a mind-bending thought. What we call dark energy might not be a force within our universe, but a shadow cast by another. For Kaku, these discoveries are steps toward a theory of everything, a framework that unites the quantum and the cosmic, explaining why our universe behaves so strangely. But this isn't just about abstract theories. It's about us, about humanity's place in this grand, shifting cosmos. The universe has been expanding for 13.8 billion years, since the Big Bang set it all in motion. Edwin Hubble, nearly a century ago, showed us that galaxies are racing away, their light stretched redder as space grows. Dark energy, discovered in 1998, revealed that this expansion is speeding up, defying expectations that gravity would slow it down. The Lambda CDM model tied it all together, a neat package explaining the universe's composition and growth. Yet now that package is unraveling. The galaxies that shouldn't exist, the expansion rates that don't agree, the dark energy that might be fading. These are cracks in the story we've told ourselves. And in those cracks lies the thrill of discovery. Science thrives when certainty falters, when the universe refuses to fit our molds. Each anomaly is a breadcrumb, leading us toward a truth we can't yet grasp. As we stand on this cosmic precipice, the questions burn brighter than ever. If dark energy is changing, will the universe slow to a crawl or collapse in a blaze of rebirth? Are we living in a single fleeting phase of a cosmic cycle that spans hundreds of billions of years? Or is our universe just one note in a symphony played across countless dimensions? The answers lie in the stars, in the data streaming from our telescopes, and in the minds of those like Kaku, daring to dream beyond what we know. The universe is no longer a predictable machine. It's a mystery, alive and shifting, inviting us to listen closer. The universe is no longer a story with a predictable ending. It's a saga unfolding in ways we never dared imagine. Michio Kaku's chilling alert rings louder now. The cosmos is slipping through our fingers, revealing a future that's anything but certain. The James Webb Space Telescope has shown us galaxies born too soon. The dark energy spectroscopic instrument hints at a fading force driving the universe apart. And time itself ticks to a rhythm we're only beginning to hear. These discoveries aren't just rewriting textbooks, they're reshaping our understanding of existence itself. As we peer into the abyss of cosmic time, we're forced to confront a question that feels both thrilling and terrifying. What is the true fate of the universe, and what role do we play in its vast, unfolding drama? For decades, scientists believed they had the universe's destiny figured out. The Standard Model painted a clear picture. Dark energy, that mysterious force making up 70% of the cosmos, would drive an eternal expansion, stretching space until stars burned out, leaving a cold, dark void, a fate called the Big Freeze. But the cracks in this story are growing. The DESI data, suggesting dark energy might be weakening, upends that certainty. If this force is losing its grip, the universe's runaway sprint could slow to a crawl over trillions of years, galaxies drifting to a quiet standstill in a static cosmos. But the possibilities grow wilder still. If dark energy fades further or flips into an attractive force, the universe might reverse course. Galaxies would race toward each other, the night sky blazing as stars collide, culminating in a big crunch, a fiery collapse that could birth a new Big Bang. Or perhaps the truth is stranger. What if we're caught in a cosmic cycle, a dance of expansion and contraction stretching across hundreds of billions of years? The idea that our universe is just one phase in an eternal rhythm feels like a whisper from the stars, daring us to imagine a cosmos that reinvents itself endlessly. Kaku, with his visionary lens, sees these anomalies as more than puzzles. They're keys to a grander truth. His work on string theory and the multiverse suggests our universe might not be alone, but one bubble in a froth of countless others, each with its own laws. The Hubble tension, those clashing expansion rates, could be a signal from these unseen realms, a hint that our cosmos is tangled with others. The early dark energy pulse, those impossible galaxies, the shifting strength of dark energy, all might be ripples from extra dimensions or parallel universes brushing against our own. It's a thought that stretches the mind to its limits. What we call dark energy could be the echo of realities beyond our reach. Kaku believes we're on the verge of a breakthrough, a theory of everything that weaves together the quantum and the cosmic, explaining why our universe defies our expectations. His warning carries weight not because it predicts doom, but because it challenges us to rethink everything. If we're wrong about dark energy, we're wrong about the future. And that uncertainty is where discovery begins. This isn't happening tomorrow or even in a million years. Any cosmic shift, whether a slowdown, a crunch, or a cycle, would unfold over timescales so vast they make human history feel like a heartbeat. Yet the implications touch us now. The universe's story is our story, a reminder of how small we are, yet how fiercely we chase its secrets. From Edwin Hubble's discovery in 1929 that galaxies are racing away, to the 1998 revelation that dark energy fuels an accelerating expansion, we've built a model that explained the cosmos until now. The Lambda CDM framework, once a triumph, is faltering under the weight of new data. Those early galaxies, glowing with stars when the universe was barely born, defy our timelines. The Hubble tension mocks our measurements. Desi's hint of a weakening dark energy suggests the universe's engine might be sputtering. Together, they tell us the cosmos is dynamic, alive, and far more mysterious than we ever thought. This moment in cosmology feels like standing on the edge of a new world. Every major breakthrough in science has come from moments like this, when trusted ideas crumble and the universe forces us to look deeper. The Big Bang, 13.8 billion years ago, set this all in motion, a searing, singular spark that birthed everything. Redshift, the stretching of light as space expands, lets us measure that growth, while the cosmic microwave background offers a snapshot of the universe's infancy. These tools have guided us, but now they're revealing a cosmos that doesn't play by our rules. The excitement lies in the unknown, in the possibility that we're glimpsing the first notes of a grander symphony. Will the universe fade into darkness, collapse in fire, or dance through cycles we can't yet fathom? The answers are out there, encoded in the light of distant stars and the patterns of galaxies spanning billions of years. As we grapple with these questions, the human spirit of curiosity burns bright. Scientists like Kaku, armed with telescopes and theories, are chasing a truth that feels both impossibly distant and intimately close. The universe isn't broken. Our understanding is simply catching up. Each discovery, from the James Webb's ancient galaxies to Desi's cosmic maps, is a step toward a new story. One that might reveal not just the fate of the cosmos, but our place within it. Are we fleeting sparks in an eternal void, or witnesses to a universe that reinvents itself forever? The cosmos is speaking, and with every new signal, we're learning to listen. The future is uncertain, but that uncertainty is what makes it breathtaking.